identifies the direction of energy transfer as a natural process. So in other words, like on its own, where does heat go? And it goes from, so it never goes from cold to hot on its own. So in other words, it goes from hot to cold. Okay? Heat goes from high temperature objects to low temperature objects. That's naturally. No. You wrote it as like a double negative. You wrote it never goes as opposed to it does go. But this is not wrong. I'm going to add here, you can do work to go from cold to hot. So it is possible to do work to go the other way. That's how refrigerators work. So refrigerators do work, that's why you have to plug them in. They do work to go from cold temperatures to hot temperatures. So if you feel behind the refrigerator is hot because it's taking heat from cold and putting it in a hotter environment. Naturally, if you unplug the refrigerator, eventually it would get warm because the heat goes from high energy outside to cold energy. Okay? All right, so there's your basic summary. Let's get the questions here. So, can heat transfer from cold to hot? States that heat never goes from cold to hot. I'm going to add one thing here, and that is naturally. Well, there you go. Now you got it. In nice, pretty pink. So, can heat go from cold to hot? No, not naturally. It can if you force it, but it won't naturally do it. Okay? Think of it, it's like students. Okay? If I assigned you a homework assignment every time, but I had no requirement that it had to be done, no one would do it. Okay? They only do it if you require it and you force things to do stuff. And even then, sometimes it doesn't work. But there has to be some, like, naturally on its own, it never goes from one thing to another. So it never goes from cold to hot naturally. And it's not like a 90% of the time. Never, ever, ever, ever does it go from cold to hot unless you make it. All right, next one. How is it important? Shows the direction heat transfers. Okay. We need to know what heat does. We know it is a change in internal energy, but we need to know how it changes the internal energy. So it goes out of hot things, which makes their internal energy go down. It goes into cold things, which makes its internal energy go up. So now we know the direction. That helps us in that equation I showed you. That helps us figure out what's positive and what's negative. So this second law is how we figure out direction. So if heat goes in, if you gain heat, you'd have positive delta, or positive Q. If you have internal energy go up, if you gain internal energy, then you would have delta U be positive. And then work that is done on is negative. So work that is done to like make it go the other way or something would be negative. Okay. All right, and third one here, we just got those two. I want to see if there's anything else I wanted to add. I mean, the second law is pretty straightforward. All right, clarification here. Heat engines. Heat engines cannot convert all heat into mechanical energy. This is because some of the heat has to flow from reservoir to sink. So they can't, mechanical energy, just a fancy word for work. There's a reason why your cars have exhausts. The exhaust manifold on your car is where this extra excess heat goes. Okay, so your piston does work. The piston turns the drive shaft. The drive shaft moves your tires. So that's the work done. Okay, the work is done, but then there also has to be some change in internal energy and therefore some heat. the heat goes from higher energy, high temperature inside the car engine to low temperature outside of the car engine. Another thing that's kind of interesting about this, I don't know if it's interesting, but you're more efficient when that temperature difference is larger. So your cars actually get better gas mileage in the winter than they do in the spring or the summer. Okay? They may get terrible gas mileage no matter what, but you do get better gas mileage in the winter. But that's also why you're supposed to let your car warm up. The reason you're supposed to let your car warm up in the winter is because when you turn your engine on and it's cold, the temperature difference between the outside air and your engine is small. And so therefore it's not as efficient as it can be. So if you let it warm up and now there's a large temperature difference between your engine and the outside air, then it's going to be better.
I also know why it's better in the cold.
Why?
Because there's more oxygen in the cold air. Because it's really close, so there's more oxygen. When it's such a more oxygen.
I would dispute that statement. But I don't know, like I haven't studied that for sure, but I would find that very surprising. All right. And lastly, visual. I love it. Nice and simple. Hot to cold. Yay! Cold to hot. No. Boo. We don't like that. Okay. Any questions on this one? Any questions on the second law, how it works, what it is, what to do, that kind of thing? All right.